Hello and welcome to the example one we have started previously. Previously we have completed two videos for example one. Example we have started with setting up the hardware and software for the example one problem for the ladder logic, and the problem was, I'm just repeating again, there are three machines, each with its own start and stop buttons. Each start button is to have a ceiling circuit. Write a ladder program to operate all three machines. Now, this is very simple and straightforward. In the example I have shown in video second video. This is the program we have written in the last video for the example one. So here it is. I'm repeating again. What we did, we have a network that is reading all the DI status from the push buttons. We have how many inputs do you know? Example 1, we have 6 inputs. Start button, stop button for 3 machines, that is 2 multiplied by 3, 6 input, digital input, and 3 output. So 3 output, 6 input we are reading and saving it into a data block. The name is all underscore di. That data block bit is being used in ladder program. Instead of using direct input, digital input, we are using the data block bit, the status of the digital input, which is saved in data block bits, and that is being used in ladder program. So this network 2 is a rung. Each network is a rung in Siemens software. Just to note this one, in Siemens software, the network is called, the rung is called actually ring network. Now other software like Rockwell and Bradley, the name is a rung. Why rung? Because the ladder, the ladder where you keep your step and you go upwards or downwards. That the platform is called rung, and the ladder has that meaning actually. So in Siemens we call it network. So the network 2 is the machine 1 program, the ladder logic for machine 1, and network 3 for machine 2, and network 4 for machine 3. And network 5, we have all the output that is generated in the ladder program is transferred into the real digital output in the module, hardware module. So let me show you the image here of the module. Okay, so in the panel you will see the rail like this, and the first module is digital input. So in the digital input module, 6 push buttons are connected, start and stop push buttons. Those statuses are read into lateral logic and saved in data block, and then we execute the lateral logic, and after execution we save the executed result in digital all underscore do data block, and that data block status finally at the end network in rung, we transferred them into digital output module, and then digital output module is connected to the field devices like motor, fan, or etc. output device. So that's how we have designed our program. Now additionally, what we have additional problem for this example one is this two. Any two machines may run at one time. Now this is the extension to the existing problem. Existing problem is very simple. Independently there are 3 machines, but now the additional problem is 2 machines may run at one time. Hmm? Each start button is to have a setting circuit. That's normal. We have already constructed PLC circuit with appropriate interlocking for this problem. And then second part is write this program in OV1. Then do this in FC function. Write three advantages of FC compared to OV1. Now this part, let me do this from this way actually. You know how the program is done in OV1. This program, you can see project 1 PLC3 is our PLC project, and then program block. We have opened this folder. Inside folder we are using OV1. OV1 is the main programming block. When PLC goes into run mode, it starts executing the OV1, and from within OV1 actually hierarchy of program executes. There will be multiple block calls, instruction jumping into other subroutines, other block will be called, and so on and so forth. But the main block is the OV1. So now we have done this whole programming in OV1, but this is not the standard practice. For small machine, small project, it's okay. For example, it is okay, but for big project, we cannot do all the ladder logic inside OV1. We have to use some blocks like this one, FC1, and we put like all three machines program inside FC1, or independently 3 FC for 3 machines. We can do that way. But now, because our example is so simple, all three machines are similar exactly, and each one just consuming one network, so we can use one FC for 3 machines. So that way, one network for one machine, so we will have 3 networks. Let's create one more network. Okay, now what we can do, we can actually copy this 3 network, or cut actually. Okay, we cut this network and let's paste here. Okay, so now we have replaced, we don't need this. So 3 machines start stop program. Okay, so we have 3 machines start stop program in FC1. Now that is not enough. We have done a separate FC function, but we have to call this from within OV1, because you know the OV1 is the main block that is being executed. FC1 is not executed. Nowhere it is called. To execute FC1, you have to call in OV1 or in other block, but that block should be called within OV1. Now let's create a network below network 1, and then we write here call FC1, and then we do this instruction. You can find this instruction empty box, and then inside this you write FC1 and enter. Is it example 1? Example 1 FC1 is called. Or you can do, let me check this if it is how another way. Example. So if you can write this name, this will also come. So call FC1. Now if you double click this one, or this block will open. You see? So now the program is complete. We can actually simulate this same problem. Let us open simulator PLC3. sorry. So now downloading is done. PLC simulator is running. So we can do the testing part. If you remember, last time we have opened the watch table to simulate and test our project, and also we can simulate through this FC directly. So remember what is the function of push button? Let's see. Push button, stop button is NC and start button is NO. So NC means the signal is already there before you even push it. So let's signal is there means it should be 1 by default. We can do it in watch table. Okay, so let's start watch table. I know why it was not happening, because we have to start from this network. So if I want to start machine 1, I have to press the NC first. Let's do this. This is NC. So now it is already signal is there, is a green indication. Now if I want to start this, I have to go into the main input, that is this one I0.0, and I press from keyboard. I also can do that is Control and F2. So Control F2 to start. So now it is started. So I can see the machine 1 motor 1 is running. So this way the remaining we also can test. And this is ceiling circuit, because once it is started, the parallel to start button, this one is also get set. And if you release this one, we press this, we stop it, we release the start button, but the machine will keep running unless the power turned off, or we press the stop button. We press the stop button and that will make disconnect the contact. To see more simulation of this program, you can watch my previous video. Now the remaining part of the problem, where it says that only any two machines may run at one time, and this part you can do that by putting interlock. We call that interlock. When we restrict something with the condition that that prevents something to run, that is called interlock. So we can do that. That means each of these three machines at a time we cannot run all, but two we can run, any of these two. So that is interlock. We can do that by constructing something like this. You can run this machine if these two are true, like machine 2 is running, machine 2 is running, but machine 3 is not running. Okay, or machine 2 is not running, machine 3 is running. So that way that will make this as a second machine. So similarly we can copy this port like this, drag like normal selection, and then Control C, or you can right click and then also you can copy from menu, and you can right click here and paste it, or we can press the keyboard Ctrl V, and then you connect this. Now here you have to change for the machine to what we called previously. You remember the keyword interlock. For the machine to interlock, we have to change the motor name. This is machine 2, so we have to give 1 and 3. The condition is 1 and 3. Machine 1 is running, machine 3 is not running. Sorry, 1 and 3. Okay. Similarly, copy this and paste it for this one. Close this. So this will be 2 and 3. 1 and 2. Sorry, machine 1 and 2. So what is the meaning of this? This machine can only run if machine 1 is running, machine 1 is running and machine 2 is not running, or machine 1 is not running but machine 2 is running. So that way this will be a second machine, because only maximum we can run 2 machines. So let's download this one. After every change we have to actually download the program, the changes into our simulator or main PLC. And now simulator is running. We'll go back to our watch table and let's do it from here. We change it to machine 2. Now the watch table, you can see the advantage of watch table. You can see multiple variable in one table. Now 2, 3, 3, 3. Now let's go online. We have to make NC for all the stop button. Okay, so now it's ready to start. We start the machine 1 and the machine 1 is not running. So now it's the time for diagnostic why it's not running. We go online and see there is condition that there should be another condition that either, like third sentence, if you read this third sentence, anyone may run by itself. This section we have to do something like this. So machine 2 is not running and machine 3 also not running. So this section we have to execute in all other networks as well. So this should be 1 and 3. This should be 1 and 2. One and two, 1 and 2, 1 and 2, 1 and 3, and 2 and 3. So let's download again, save and download. stable, and now you see the machine 1 is running, because the network, you will see the complete network is available through other two machines are not available. So this is the first machine we are starting. And now if you want to start the second machine, we press the start button, right click and modify one. Second machine also running. Let's try to start third machine. Start, and it is not started. Why is not started? Because we have interlock that machine 1 is running already and machine 2 is not running, then only the machine 3 can run. But at this moment we have already started both the machines. So let's just stop one machine. We stop the machine 2. First we actually stop, release the start button and then stop it. You see, immediately after we stop the machine 2, machine 3 has started. Why? Because start button was pressed and it was not released. So let's release it and then restart again. We stop it. Okay, so we stop. Now we make it NC and then release again. Start the press the start button. Now the machine 3 has started. So if you test in any combination, this will work. Only maximum 2 machines can start at a time. If you try to start the third machine, it will not start because of the interlock. The interlock we have put through this combination. So that's all. What we have done is, in this video we have actually reviewed the problem. There are 3 machines, each with a start and stop button. Then we have actually implemented that problem in OB1. In second video we have done that in OB1, but in this video we have transferred that part of the ladder from OB1 into FC, the function, and then that function is called from the OB1. So let's see, yes, we can see in OB1 we have one network where we call FC, and then inside FC we have that ladder logic with interlock in each machines. So hope this example one now is quite clear, and you can learn a lot of things from example one. How the assumptions, you have to list the assumption such that you don't miss out the questions to ask to the client to get more information about. This is very important. Thanks for watching.